So today we'll be talking about software testing technique, right? So we have done overview, of software testing. We've done software testing life cycle. Yesterday we've done the test levels. We've done test types and then bug life cycle yesterday. So, and if you can recall, right, in our first class, I said that 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 it's impossible, right, to test every possible input combination. Let's say I made an example. Let's say you are testing a software, and that software takes like it can only accept people from age 10 or from age 18 to age 100, right? It's impossible to test that soft. If it's impossible to test all the conditions, it's impossible to test 18, 19, 20, 21, 22, 23 up until 100, right? So I said the only way you can do it is to apply an appropriate test software testing technique, right? To ensure that you give that particular functionality a full test coverage. So today we'll be looking at software testing techniques. What are those techniques that you can use to test your softwares, right? So without further ado, let's dive straight into it, right? So now the table of content, what we'll be covering today, right, is what is software testing technique, categories of test techniques. We will look at black box testing technique. We'll also look at white box testing technique, as well as what experience-based technique, right? So please pay attention. It's going to be a very interesting one because at the end of this class, right, you should understand what a software testing technique is, and you should be able to apply it, because after this, we will now go into test cases, right? So let's look at what is software testing technique. So software testing techniques help you design better test cases, right? It is a technique that help you to design a better test cases. They help in identifying test conditions, test cases, and test data to ensure a software or system is functioning correctly and meets the requirements and specification, right, set out for it, right? So with software testing technique, you are able to, identify test conditions, how you can actually test, or what condition you can apply to test that particular software. It will help you to design a better test case, right? And it will also help you to generate your test data. Let's say, like I would say, use the same example that I've given you. If you want to test a software that only takes, let's say, like gym software, gym website that usually, take people from age 18 and say 70, because you don't want 100. I mean, you could have a 100-year-old, man or woman coming to the gym, but let's say that gym company wants from age 18 to age 70, for example. So, and now you are asked to test that particular website or that particular functionality. How would you want to test it? So by applying the right testing technique, right, you are able to look at what conditions that you can test that website. You can look at how you can write and design your test case, and then you can now derive the appropriate test data, right, to test that particular software. We'll give an example when we go start discussing them one after the other, right? So testing techniques helps reduce the number of test cases to be executed while increasing what? Test coverage, right? So like I said, you can't test 18, 19, 20, 21 up until 70. right? So what you would do is you will use the appropriate test technique, of which will come into it, and by the time we start doing it, you will understand it much more better. You use the appropriate test technique to reduce the number of test cases that you're executing, and by so doing, you are also increasing test coverage, right? So that is it. So the next part, our next slide will go into the choice of which test technique to use, right? So the choice of which test technique to use depends on several factors, which include component or system complexity, which is the first one. So when you are testing a software, before you choose the, before you choose what test technique to use, right? You have to look at the component you are testing. You have to look at the system, how complex the system you are testing is, right? So that will enable you to what? Identify and say, okay, yeah, this test technique would suit this component better. This other test technique would suit the other um, uh, uh, components better or functionality better, right? So let's say, for example, you are testing like UK government website, for example, and then they are looking at different criterias, right, to be able to apply for certain things. So when you need to look at that functionality you are testing, and then you will now say, oh, what kind of test technique will best suit this particular functionality, and that will enable you to test that particular functionality very well by applying the right test technique. So the second one is risk level and types. So you look at the level of risk, right? So if the risk is high, what do? You need to ensure that you spend more time and you spend more resources and you execute more test case, right, within that area that have high risk. And then again, depending on the type of risk, right? So certain type of risk can cause company's reputation, it can cause, that organization, it can cause, their reputation, and then um, customers or end users could lose confidence, right? So that's why you look at the level of risk, and then you ensure that you test it properly by choosing your right test technique that suits that particular functionality, right? Better, or that if you use, it will mitigate the risk, right? Or reduce the risk, because obviously you can't mitigate the risk entirely, but you can reduce the risk, right? So the next one is the type of defects expected in the component or system. So when you are expecting certain type of defects, let's say, for example, you are testing a software, right, that only accepts age 18 and above, right? So you know that there are chances that defects could occur, that a 17-year-old would want to register or have access to that particular software, and it will allow the person, right? It will allow the person. That is why you look at that type of defect that could occur, and then what you do is you choose the appropriate test technique to test that particular um, functionality, and then that will enable you to detect that defect or the bug that would occur around that component or system. So the next one we'll have is time and budget. Time and budget is very important, because whatever you're doing, every organization has the amount of money they've set out, right? So, and obviously the time they want to go live, like I said, I've mentioned this time and budget, it keep coming up every time, because every organization, they are in business to make money, right? And then to deliver values. So once they are, venturing into any project, they've set out the amount of money they want to spend on that. So you, as a tester, you wouldn't want to, exceed the time constraint that been set out, or the budget constraint as well. So these are some of the, these are the factors that determine what test technique. There are so many other factors as well that determine what test technique we could use, which obviously include the available tools. So the available tools you have, the software you have can also affect the test technique you want to choose. There are other ones such as the software development lifecycle model that you want to choose. We'll have, like I said before, we'll have the V model, we'll have the waterfall, and we'll have the iterative, we'll have the agile, right, which is iterative incremental model. And then, so those, depending on the model, right, your organization want to choose, will also help to determine what test technique, right, to use, right? So these are some of the factors that will determine what choice of test technique to apply, right? So now we will go into the categories of test technique, right? Categories of test technique. So with the categories of test technique, we'll have the black box test technique, we'll have the white box test technique, the black box test technique, right? We'll have the white box test technique, and we'll also have what experience-based test technique. So let's look at what the black box test technique is. I'm sure in our last class, I've mentioned black box testing and then white box testing, but now we are looking at the black box test technique, right? And the black box test technique is also called behavioral or behavior-based technique, right? And what does this technique mean? So this technique focuses on the external behavior of the software without considering its internal code structure, right? So when you are applying this technique, right, you focus only on the external, right? You are not looking at the code. If you can remember yesterday when we were talking about black box testing, note the difference. They are quite similar, but you need to know the difference between black box testing. What I was saying about black box testing is when you are testing, a software, you are looking at, the behavior of the software. You are considering what you are inputting. You are considering just the interface, right? And then you do not have any knowledge about the code, the structure of the code, right? So now drilling it down to black box testing, black box test technique, right? You are focusing on the external behavior without considering the internal code structure, right? This approach is useful for testing both functional, right, like the features, like you know, the login, and then the registration, the checkout page, then it also deals with what the non-functional aspect, such as the performance testing, right? The performance of the website. We discussed this yesterday, right? So now there are common characteristics of black box testing. There are common characteristics of black box testing, and these common characteristics of black box testing will help us understand what black box testing is. If you have questions, please raise your hand. I will come. I will, call you so that you can ask your question. So, black box testing has its characteristics, and what are the characteristics? So, the characteristics are test conditions, right? Test cases and test data are derived from a test basis that may include software requirements, right? The software requirements, specification, use cases, and user stories, right? So you can see you are not looking at the structure of the code, you are not looking at all the logics, you are only looking at the requirement that is being gathered by the BA, you are looking at the specifications, you are looking at the use cases, and you are looking at user stories, right? Those are the characteristics. right? So the second one is that the test cases may be used to detect gap between the requirements and implementation of the requirements, as well as deviations from the requirements, right? Because obviously you are not looking at the code. What you are looking at is the requirement and then the software you are testing, where you are applying this black box testing. So all the test data, all the test cases are based on those requirements and specifications. That is black box testing. Like I told us yesterday, black box testing is the one we, the QAs, does, because we are not looking at the code, we're not doing unit testing and all that, right? So now we'll come into black box testing, one after the other. We'll come into it in great detail. So the next one is white box testing. Just like I said, that the black box testing is also called behavioral or behavior-based technique. White box testing is also known as structural or structure-based technique. Recall, black box, you're looking at the behavior, you are focusing on the external behavior, whereas the white box testing is structural. You are looking at the structure of the code. This involves examining the internal. The other one is the external. This one is the internal code and logic of the software. Just like yesterday, again, we were discussing about white box testing, where the tester will have, would, understand, and will see the the internal structure of the code, the logic, and all that, right? But with the black box, you're not seeing it. You're only focusing on the external behavior, right? So then let's look at the characteristics of white box testing. Like I said, the test condition of the black box testing, the test cases of black box testing, and test data are derived from what? From the requirements and specifications, right? But for the white box testing, the test conditions, the test cases, and tests that are derived from the test basis that may include code, software structure, detailed design, or any other source of information regarding the structure of that software. So you're looking at the code, right? You are looking at this architecture of the software. You are looking at the design. You are looking at all the logics that is being written, right? So that is the characteristics of white box testing. So now let's go to the experience based testing. Experience, from the name, as the name implies, experience based testing. So experience based testing. So experience based testing, as the name implies, you are experienced. So the person that is testing that particular software is experienced, right? The person is experienced, has knowledge of that software and how it behaves. Experience-based testing is a combination of black box and white box testing technique. So experience-based testing leverage the experience of a developer and a tester and user to design, implement, and execute tests, right? So you leverage, obviously, the tester or the developer who is doing the testing. Don't forget, I said that developer does do their testing. They usually do unit testing, which is around white box testing. We, the tester, will also do our testing, which is centered around black box testing. That doesn't mean that you don't see testers doing white box testing, and that doesn't also mean that you don't see developer doing black box testing, right? So now, let's say you are familiar with Facebook. You know how Facebook is meant to or one particular functionality, right, in Facebook is meant to behave, right? Then you are going to test that particular software, right, or that particular functionality, right? You've already known, you have experience on how it will behave. So when you are going to test it, you've already known. You are looking at it, even without writing your test case, even without requirement, you already have experience. That is what experience-based testing is centered around. And we'll come into these three categories. We'll come into these three test technique categories in great detail, right? So let's go to the next page, because now we are now focusing on each of them one after the other, right? So the next one we'll have is black box testing. Black box testing. So let's look at the next one. So we've mentioned black box testing. So we are now going into black box testing, and under black box testing, we'll have different types of black box testing, of which number one of them is what? Equivalent partitioning, right? Under black box testing, we'll have equivalent partitioning. You either call it equivalent partitioning, or you also call it equivalent class partitioning, right? So equivalent partitioning or equivalent class partitioning is a type of black box testing, right? And it's what it does. So it is a technique of black box testing that can be applied at all levels of software testing, such as unit testing, integration testing, system testing, right? So what does it do? In this technique, input data are divided into equivalent partitioning. I will demonstrate how it's been done, right? So the input data are divided into equal partitions, right? So this will help to reduce the time required for testing, because the small number of test cases, right? Because once you start doing it, you will now have, once you've divided it into equivalent class, you will have smaller number of test case. So let's take, for example, right? You want to test a website. So before I will come into it again, right? If you want to test a website, and then you are, and that website, like I usually say, will take 18 to 20, right? So what do? Let's 18 to, not 18 to 20 is not a good number. So it will take from 18 to, let's say, 100, right? And like I've said, you won't always want to test from 18 up to 100. So what you do in this instance is to divide that range into class, right? So you divide it into class, you partition it, you partition it, you partition the negative side, you partition the positive side, and then you also partition the negative side again. So whichever one falls under invalid, you will use that for your negative testing. Which one falls under valid, you use it for your positive testing, and the other one that falls under invalid, you will use it for your negative testing again, right? So like I said, equivalent partitioning divide data into partitions, also known as equivalent class, in such a way that all the members of a given partition are expected to process in the same way. So every number around that particular class is expected to behave the same way. So if the number is around negative or invalid, is expected to behave, or the number that falls under that class is expected to behave the same way, right? If it falls under valid, they are expected to behave the same way. If it falls under negative, it's expected to behave the same way, right? So I will want to demonstrate how it works, right? And I want your inputs, right? So that I want to ensure that you understand what I'm trying to say, because it could be a little bit confusing when we go to the next one, which is boundary value analysis. So I want everyone to understand equivalent class partition, and I will take it again. Equivalent partitioning, right? Divide data into partitions, also known as equivalent class, in such a way that all the members of a given partition are expected to be processed in the same way, right? So they are equivalent partition for both, right? So you are dividing it into valid and invalid, values, right? So now, so this is the logic around equivalent partitioning, right? It works on certain assumptions, right? So what are the assumptions that equivalent class partition works on? So it works on the assumption that every member of the partition are expected to behave the same way. Every member of that partition are what? Expected to behave the same way. Is that clear? So the second one is that the system will handle all the test input variation within the partition similarly. So the way it handles everyone, the way it handles all the way the system handles all the values around the negative, the invalid partition, right? The way it handled the first one is the same way it will handle the second one, is the same way it will handle the third one, right? So the way it handles one around the valid is the same way it will handle every other one. And the way it handled the one within another invalid is the same way it will handle every other one, right? So let's take the last one, which is if one of the system condition fails, then all other input condition within that partition will also fail. Let's say we'll have the first partition is from 1 to 18, from 1 to 17, right? If 1 fails, that means 17 will fail, right? So let's get to the next slide, then you would understand what I'm trying to say, right? So imagine this is a website, right? Or this is a feature on a software application. Let's say a gym, website. And in this gym website, you can see the gym, you can see someone who is trying to lift, weights, you can see that. So now, before you access this website or this software, you need to be age 16 to 60, right? So that means the only people that will have access to this website or this software, right, are those that are 16 to 60 years. That means if you are 15, you cannot access this website. If you are 14, you can access it. If you are 12, 1, 2, you can access it, right? If you are 60, you can access it. But if you are 61, you can't access this website, right? So you as a tester, how would you test it? Right? So for you to test it without using test technique, you want to impute 16, right? You will not impute 16 and click enter. If it enters, you know that, yeah, 16 years can enter. You click 17. If it enters, you know 17 can enter. You click impute 18 here and click enter. If you have access, you know that 18. So how can you keep doing that up until you get to 60? How? There's no way you can, because obviously the time you haven't got the time, you the budget might not be there, right? Because you still have every other story and other features to test. So this is now when you now apply this test technique called equivalent partitioning, which is a type of black box testing, right? So what would you do? You will now partition these numbers, right, into valid and invalid partition, or into valid and invalid class, right? So once you partition it, every number within the valid are expected to behave the same way. Every number within the invalid is expected to behave the same way, right? So let's go to the next slide so you see what I'm saying, right? So let's say now, like I said, I'll go back to this slide. Take note of this, right? People that have access, that should have access to this website, should be people between 16 and 60. So that automatically means that between 16 and 60 becomes our valid partition, right? between 16 and 60 becomes our valid partition. So everything from 61 and up to 200 or thereabout is invalid because they are not allowed to have access to this. And everything between age 0 to 15, right, shouldn't have access. So have you seen that by so doing, we have divided all the possible inputs into partitions. So from 0 or -1, or 0, which you can't have someone that is -1. So from 0, right, to 15 becomes our invalid, because if you enter it, it will not have access to the website, right? So from 16 to 60 becomes our valid, and from 61 and above becomes our invalid. So that is how you will test this website using this testing technique. Divide it into partitions. Once you've divided it into partitions, right, you enter one value, because like I said, that any value around each partition is expected to behave the same way. For example, let's look at the partitions. So I have partitioned it, right? So this is equivalent partition. So this is from 0, you can see from 0 to 15, or from 15 to less becomes our first invalid partition, right? Invalid partition. From what? 15 and below becomes our invalid. So from 16 to 60 becomes our valid partition, right? And then from 61 up until 500 or thereabout becomes our invalid. So now, if we are to write test case around this, right, we can only write 3 test cases. So we'll write our first test case, which is a negative test, using this 15 and below. So what we will do here, remember I said that any value around this partition behaves the same way. So if I decide to use 15 to execute my test, if I enter 15 on this website, it will not go. I won't be able to log in, right? If I enter 14 on the same website, it won't accept it. If I enter 12, it won't accept it. So what you will do as a tester to save your time is to enter any value around the first negative invalid partition, which is this one. It doesn't matter any of the number, because as testers, we are meant to test both the negative and the positive, the valid and the invalid, just to give test coverage, because you don't focus on the happy part. You do not focus on just the valid one. And then when you test the valid one, you say, oh yeah, I'm 17, I was able to log in. Have you tested if 16 will be, if 14 or 15 will be able to log in? Have you tested if 61 and above is able to log in? Right? So imagine that you are not using this technique, and then you've tested from 16, 17, 18, 19, 20 up to 60, right? So you've tested all your positive or valid scenarios. Then how do you test your negative ones? Would you start from 0, 1, 2, 3, 4 up to 15 to ensure that any person within that age range wouldn't log in? Have you also tested that 61 and above wouldn't log in? So that is why this test technique is very important, right? So like I said, the software is meant to take persons or individual from 16 to 60. What you will do is that range that is expected to take, you will partition it into your valid partition. Then the one that is not supposed to take, which is the lower boundary value, right? The lower equivalent class partition, right? The lower equivalent partition, you will partition it into invalid, just like I have done here. Then the higher partition, which is another valid, you obviously partition it, which is 61. right? So what you will now do is you will choose any value between 16 and 60 tests. It could be 59, it could be 60, it could be 18, it could be 20. Anything between 16 and 60 is valid. And like I said, they are expected to behave the same way, right? So if the principle that this works is, if you test 18 and 18 fails, that means if you test 19, 19 will fail. If you test 60, 60 will fail, right? So if you test, obviously, if you test 14 and it goes through, that means if you test 15, it will go through, right? So every member of this partition behaves the same way. Every member of this partition behaves the same way. Every member of this partition behaves the same way. Is that understood? Right? So I will call out name, I will call name one after the other. I want to ensure that you understood this, right? So let me go back to the website, right? So now, Joshua, get ready. You can unmute yourself and get ready for a question, right? I have said that this website, Joshua, can you hear me? So I've said that this website, you can unmute yourself now. I'll say that this website, and everyone get ready because I'll ask everyone a question before I move on. I want to ensure that everyone understood it. So I've said that this website, right, can only take 18, 16 and above. Joshua, between 18 and above, I have partitioned this just like you have seen here. I've partitioned it into invalid, valid, and invalid. Can you give me one valid test data that I can input here and it will be successful?
You can impute, sorry for the disturbance.
Yeah.
You can impute any data from maybe 20, 21 and above should be valid.
All right. Thank you. Thank you. So 20 should be valid. All right. 21 should be valid. All right. So you just have to choose one because every other one is right. Every other one behaves the same way. Right. So now the next person is Chid. Chid, can you give me one invalid? One invalid from my partition. One invalid. Chid, are you with us? Okay, while we wait for Chid, Blessing, are you ready? Blessing, are you ready? I told us to get ready. I'll be calling out everyone one after the other. I want to ensure that we understood it. Vincent, are you ready? Anyone that is ready should unmute and tell me one negative.
Okay, the negatives.
Yeah.
I was about to ask a question, but like I just want to know, like a question which I think maybe other people might learn, or you can throw more like. But I would just say, the invalid number can
Yeah.
put 14, or
14.
maybe 62, 63. So,
Yes, that's right.
well,
So go ahead and ask your question.
okay, the question I want to ask, as a tester, sometimes you just have to create some, as you just said, negative tests, because sometimes you might just want to put maybe 15.5 or maybe 15 points to see if it will actually go through, because sometimes maybe during the coding or something they might miss something whereby you can impute such number and you find out that it goes through. So, or are we just to test only whole number? Can we also put imputes like, the bowling numbers like 15 point something. Want to see if it will go through because it's also a negative number. Thank you.
Yeah. So yeah, we're done for that. We're done for that question. So now I will ask you that question. If you put 15.5, that means that person is 15 years and 6 months. Do you think this system will take it?
That is what I'm saying because it's not like the whole number. You already have like something on top.
Mhm.
So maybe you want to check like an extra check to see if maybe there is any condition or anything in the code whereby that is a mistake that will allow something like that to go through. That is what I'm just asking.
Yes. So now, if you are testing this website, right, and they say it's from 16 and above, you already know that anything less than 16, right, will not go through. But applying the principle of equivalent partition, you are partitioning it into equivalent class, right? So now, even if you test 15.5 here, it will not go through because that person is not up to 16 years, right? So as you can see from my class, the value starts from 16. So some of these websites will not give you, when you click on the drop down, right, it will not give you any um, it will not give you any 0.5 because obviously they've coded it is from 16. You have to click on the drop down and then you select your the years you want to impute, right? And sometimes if it's a free test, if it's a free test field, sometimes it might not take points, right? But if you can take points, right, depending on how the code is being written, if you can take points, if you enter 15.5, it will not take it. But Vincent, when we get to boundary value analysis, right, we'll now begin to talk about the boundary. Do you get what I mean? But for this case, like I've said, the value, anything from 15, anything from 16, right, to 60 is within our valid partition. Anything from, right, 15 and below is because now they are talking about years. Most often, if it's a software that is not accepting months, right? So you've seen some of the softwares that what they want to ask is if you are 16, if you're 18, if you're 20, right? So if you are putting points, it might not accept it. Or sometimes it could be a drop down, right? You need to select your age. And most often it's always drop down. But if it's a free test, then it's fine, right? But they already said it's 16 points. So there's nothing wrong in testing that around that boundary as well. But when we get to boundary value analysis, you will get what I mean. But what I'm trying to say is that anything less than 16, you could test it because they fall under the invalid partition, right? Yes, is that understood?
Yeah. Thank you.
Yeah. All right. So, yes. So if that is understood, right, we will dive straight into the advantage and disadvantage of equivalent class partition. So the advantage of equivalent class partition is that it can determine the test case more specifically, right? Let's say we are testing that website, the screenshot of that website that I've shown you, right? If you are applying the equivalent class partition, right? You've partitioned it into valid, invalid, and then the upper invalid, right? So it has specified when you are testing that website, you will do the negative testing and the positive. Under the positive testing, right? You choose any value between 16 and 60. You just choose one value and then you use it to test. Then for your negative scenario, you can do two negative scenario. You can choose any value that is less than 15 or less than 16 from 15 and below. You can use it to test, right? And then your second negative testing will be any value between 61 and above, right? So that is one of the advantage. It's help you to determine the test case more specifically. So the next one, it can recognize system defect based on the test cases being tested, right? So because it helps you to determine the test case, right? So it can identify defect based on this test case you are using, right? So let's say you are using that you are using 16, any number between 16, which is, let's say, 20, right? It can identify error when there is an error between someone entering the value between that valid partition, right? When you are testing the negative one, right, you've chosen 14, for example. If there is an error within that negative one, it would obviously capture it. And then, like Vincent mentioned, the major reason why we do this, equivalent Cartesian, I wanted to mention it when I get to boundary value analysis, right? Is because I've mentioned it in our first class. Maybe Vincent, I don't know, maybe you were not there, right? That I told everyone that developers usually make, error. It's known that developers usually make mistake, right, at the boundary value, at the boundary of every number. Let's say, for example, and when they use, like I said, when they are writing codes, right, they use positive, greater than and less than. So they don't write it, like, okay, yeah, we do not want any person between 16, that is less than 16 and above 60 to have access to our website. What they do is they write a code. They say, okay, if they use conditional statements, right, and logic, if, right, maybe clients or something is less than 15, right, true exception. Maybe the true exception is when the person tries to enter, it will reject it, right? So the only people they will not write it, or if their if else statement or s so number, they'll put. So sometimes when they are trying to write the greater than or less than, they usually put either less than or equal to. So because of that, they usually tends to make mistake around the boundaries, right? Around all these small letters. Sometimes they want to put 15, they put 16, right? So, but that is why we usually adopt this method of equivalent partition and boundary value analysis. But that is usually with the boundary value analysis, right? So now we'll now look at the disadvantage of equivalent class partition, right? So one of the disadvantages, identification of test case still use the manual method and require tester expertise. Let's say you are not used to, right, partitioning you don't have experience on how to partition, right, your your set of test data into valid and invalid, right? You can make mistake. You can say, okay, yeah, I've partitioned it, but you haven't done it very well. You can choose the invalid and then put it under the valid, and you choose one of the invalid and use it as a valid test case in a valid scenario. So you tend to make mistakes. So it requires testers expertise and experience, right? So length of time used in the test case, which I will argue that, but so sometimes because you are using this technique, right, you tend to, spend time again trying to partition this, and then spend time again and start writing the test cases. And after writing the test case, you now start executing your testing. Sometimes it can even get more complex than it is at the moment, right? So that is that. Like I've mentioned, this equivalent class partitioning falls under black box testing. Like I said, it is a type of black box testing. So we'll go into another type of black box testing, which is known as boundary value analysis. Boundary value analysis, right? Boundary value analysis. So boundary value analysis, right? Or BVA, which is BVA, boundary value analysis, is an extension of equivalent partitioning, but can only be used when the partition is ordered, right? Consisting of numerical or sequential data, right? The minimum and the maximum value, or first and last, of any partition are in its boundary. Do you get what I'm saying? So the minimum and the maximum, or the first and last of any partition, are its boundary value. So you choose any one within the boundary, the minimum and the maximum. We'll come to that. For example, suppose in an input field, an input field accepts a single integer value as an input, right? So using a keypad to limit input so that non-integer inputs are possible. The value of range is from 1 to 5, which is obviously inclusive. So there are 3 equivalent partition, right? So you can have 3 equivalent partition between that, which is the invalid, which is one that is high, the higher partition, right? The boundary value, which is 6. For example, you could have another partition as well, right? So let me give you another example. Let's say you have a website. Let me use that particular website again. So when I'm demonstrating this, you would understand it because I've used this one before, right? So now, the same thing like I said before, it only accepts 16 and 60, right? So how do we check our boundary values? How do we check our boundary values? It accepts 16 and 60. Note is different from equivalent class partition. This one is now boundary value analysis. So you are looking at values within the boundary, right? So let's get into where I have divided it, right? Now, first of all, what do we do? Like I said before, it is an extension of equivalent partitioning, equivalent class, right? So now what you do is you have partitioned this, like I said, it's between, you can see here. So what I have here is 16. Note, what I have here is 16, and what I have here is 60, right? So what we'll do is that we will partition this like we did before. So we have partitioned it into invalid, which is from 15 and below. We have now partitioned it into valid from 16 and 60. And then we have also partitioned it into invalid again, 61 and above, right? So now, unlike the equivalent class partitioning, right? Unlike the equivalent class partition, you are only testing within the class, right? You are only testing within the class, right? For equivalent. That's why for your invalid becomes 15, any number that falls from 15 and below, right? And then your valid becomes any number between 16 to 60. And another invalid becomes this. So what the boundary value analysis does, which is different from equivalent class partitioning, is that you test any number within the boundaries. So as you can see from here, which is a positive, you test 15. So Vincent, this is where what you said now comes in, because now you are now testing within the boundaries, right? Because on the equivalent class, like I said, right, you can choose any number. So that one is different from the boundary value analysis. Then when you are choosing any number between, right, within the class, within the invalid and within the valid. But for testing within the boundary has to do with boundary value analysis, where you will now choose every possible number within the boundary. And now we have from here going towards your left-hand side is your invalid. And what are within the boundary? 16 is where the boundary started. You have 15, and then you have 17, right? Then you now have, when you come to this upper boundary again, you have 60, you have 59, and you have 61. So now with this, how do we determine our valid boundary condition and our invalid boundary condition? Obviously, like I said before, if I go back on the website, it accepts only age 16 and 61. So looking at this value that we have within the boundaries, right? Like I say, in this case, instead of having possible 3 test cases or test data that you will test with, in this case, you will have 5. You know, when I was saying it, you wouldn't understand it. That's why I decided to come here, right? So now 16 is a valid value, right? 17 is a valid value. 59 is a valid value. 60 is a valid value. So with boundary value analysis, you have to test under your valid scenario, which is your happy part, right? You need to test 16, 17, 59, and 60. But for your invalid boundary condition, you will now test the one that is outside the boundary, which is 15 and 61, right? So mathematically, how do you work out your boundary? When you have divided it into equivalent class partition, right? So you will now come, you have 60, right? 16 on the left-hand side, you minus 1 from it, you have 15. That is your class, your boundary value, right? When you want to get a positive one, which is a valid, you add 1, right? When you want to get another one, here, you add you minus 1 from here, from the upper one, you minus 1, and then the negative one, you add 1. You need to understand how it works. So Vincent, coming to your question, that's why I say you need to get here, right? Coming to your question, suppose the website would take months, right? Or it's a number, it takes like it takes a number, it takes a month, for example, or point, right? You can see that boundary value analysis has also told us that 59.5 falls under valid condition, valid scenarios, right? And then 60.5 falls under invalid as well. Can you see? But this is a principle of boundary value analysis, right? So now, with the equivalent class partition, we'll have only 3 possible test conditions. But with boundary value analysis, we are having 5. We are having 5, which is 15 negative, 16 positive, 17 positive, 59 positive, 60 positive, and 61 negative, right? Is this clear? Any question before we move further? Any question? Blessing, do you have any question? Vincent, do you have any question?
Oh, there is no question, man. At least I know all these challenges. Good
Sorry?
reminder. So there is no question. It's okay. Everything is well explained. Thank you.
All right, thank you. Casey, are you with us? I haven't heard your voice. Is Casey still with us? No, it seems Casey has dropped off. Oh, Casey is not with us. Okay. Joshua, are you okay? Do you have any question?
Not, not truly. Everything you explain is understandable. So I clearly understand everything.
Oh, good. Shade, I want to hear your voice.
Yeah.
Any confusion? Have I confused in any way? Is it clear?
Overloaded with information.
Oh dear. That I can understand. But how about this? Is it understood? Right?
Maybe
Is
when
it
I go through it more on my own, I go through it then on my own,
okay?
then I'll be
Yes.
able to
Yes. So feel
catch
free
up.
feel free to go over it on your own. If you have any question, please come back. We'll attend to it. Right?
Yeah.
Good. Blessing. Let me hear from you. Blessing, are you with us? I want to ensure that
Yes,
we're
I
all.
am. Though I've been a bit busy.
Oh,
Yeah, but no question.
okay, good.
Okay.
All right, so we can forge ahead, right? Okay, thank you, everyone. At least I know that you are all following. All right, thank you. So we will continue. So yeah. So with that, let's look at the advantage and disadvantage of boundary value analysis. Of course, everything that has an advantage would have a disadvantage. So advantage of it is that it can facilitate identifying test case. Obviously, um, just like equivalent class partition, right? It helps us to identify test cases, right? Identify test cases. So it can control expenses based on the number of generated test case, right? So instead of testing a whole lot, I think this is also the same with the boundary value analysis as well, equivalent class partition as well, right? So because we're able to generate test case, we do not spend time and resources testing loads and loads of data, right? BVA is strongly suited method for user input trouble, right? So it is good when you are obviously you are imputing details, just like the one that we've already tested, right? So when you are imputing it, it helps, to identify, every suited input condition, both the negative and the positive, right? So one of the disadvantages, it cannot test all test cases, or it can't test all test cases input values, obviously. So the idea of which this is a disadvantage, but it's still a good thing because you do not spend time, right, testing all the input values. So now, BVA test technique is not suited for booleans, for boolean values, because boolean value is type of data which has value of 1 and 0, right? So it has value of 1 and 0. So it's not suited for it because you are looking at the boundaries of it, right? So, well, it depends with the test case variable that already have condition for input values, right? So like I mentioned before, it accepts every, the input variable will have to be arranged and sequential so that you'll be able to look at what is within the boundaries, right? So yeah, that is it for boundary value analysis, and we have done equivalent class partition as well. So the next one is that we are looking at decision table, right? Decision table. So now the decision table is one that we obviously use to fill some forms, right? When you are filling, let's say, you are filling some visa application, right? So there are some visa application that you'll be filling. So whatever you've entered would affect what other option, right, that you will get. Let's say, for example, they've asked you if you've traveled to any European. Let's say you are testing if a UK visa application form, right? So now where you can get to a point where they will ask you if you have traveled to any other country, right? If you say no, right, further information wouldn't pop out. If you say yes, you will get another information, right? And some of them, sometimes when you are also applying for a job, for example, right? Sometimes what the decision table help us to do is that when you are filling an application form, sometimes they'll ask you, they've put in that form that so anyone who doesn't have up to 6 years experience, right, should not apply. So what they do is that they hide the submit button, right? So once you've entered, okay, how many years do you have right to work in the UK? It says you click on yes. Do you have up to 6 years experience? You said, and you click on no, right? It will just log you off, or sometimes the submit button wouldn't pop out. So there are so many functionalities like that. There are so many features like that. When you are testing, whatever information you give affect the next one, right? If you give information, then sometimes the submit button wouldn't appear. Sometimes it will log you out, sometimes. So yeah, so let's go into decision table, and I will use a table to illustrate, a form in form of a table to illustrate what I mean. So a decision table, also known as a cause effect table, right? So this software, because obviously it's a software technique, like I mentioned. So this software technique is used for functions which respond to a combination of input or events. For example, a submit button should not be enabled if user has entered all required field, right? So if user obviously didn't fill all the required field, right, and they are false, right? So the submit button wouldn't come up. I will illustrate that, you understand it better, right? So the following are steps to create a decision table. Sometimes in an organization, when you're a tester, especially if it's a testing company, they could ask you to, they give you a functionality, and they could ask you to, right, to create a decision table, right? And then with the information you will learn now, you will use it to create that decision table, right? So let's go to the decision table so that I can explain it one after the other. So now, so we'll have a decision table, right? So, and this decision table has a set of rules. So now, for this form, let's say this is a form that we want to fill, right? It has a name, an email, message, right? So once you filled all these things, and they are what the F will stand for, you've not filled it, right? You've not filled it. So now, if you didn't enter your name, right? F stands for not filling, you are leaving it blank, right? So you didn't enter your name, you didn't enter your email, you didn't enter uh your message, any message you want to send, right? The submit button will not come up. Can you see it's F, right? Submit button will not come up. So the rule 2 is, let's say the person, once you are testing this, for you to test this now, right? You will not enter your name. That is the first way you will test it. And that's how decision table helps us to test like a particular software that is meant to function this way, right? So you as a tester, you have 8 possible ways to test it, right? The first one you will do is you will not enter your name, you will not enter your email, and you will not enter the message, and you will see if the submit button, this is submit button, will come up, right? F means that it doesn't come up, right? So now again, what you will do is you will enter your name, you will enter email, you will enter your message and see if it will come up. It won't come up because the condition says that you need to enter everything. See is you're entering, right? Your name, right? So everything, the submit button will also not come up, right? So let's look at rule 3, right? Rule 3, you've not entered your name, but you've entered your email and you've not entered your message, right? The submit button also will not come up, will not be visible for you to click. So then another rule 4, right? When you enter your name, your email, but you haven't entered your message. Can you see how they are interwoven? You haven't entered your message. The submit button will also not come up, right? Then another rule 5, when you have not entered your name, you have also not entered your email, but you've entered message, the submit button will also not come out. This is how you will test it. So another one is you will enter your name, you will not enter email, you will enter message. F, still not up, right? Rule 7, you enter your name, you will enter email, and you will enter message. Submit button will not come. The only time it will come up is when you must have entered your name, your email, your message, then all of a sudden, submit button will come up. I'm sure we have seen some of those websites where you are filling it. If you miss any field, you won't see the submit button. You'll be asking yourself, where is the submit button, right? But by the time you see that field you are missing, right, the submit button will just pop up. And before then, it will be grayed out. Then, but the moment you see it and then enter that value, the submit button will come up. So now you as a tester, let's say this is a contact us form for an organization, right? And then I say they put a rule that all the field must be filled in correctly, right? Before the submit button will be visible or will be clickable, right? So if you haven't filled all of them, you haven't filled any of the field, let's say the form has name, email, message, right, and submit, right? So if you haven't filled any of them, the submit button will be grayed out, right? So now you as a tester, how do you test it using this transition table-based technique? How do you test it? How you will test it is, one, first of all, you will leave all those fields and then try to see if the submit button will become visible and clickable, right? First, obviously, it will not become. If it becomes visible and you're able to click it, that means there's a bug. You need to take screenshots and then you need to add all the components of a bug, the title, and so on. Or screenshots, you assign it, give it priority and stuff. Everything that your test to reproduce, everything that we mentioned yesterday, right? So now and again, you go again, right? This is one scenario, right? You can say verify, right? If the submit button, this is how you now generate your test case. You will now verify if the submit button will become visible when user has not filled any of the field, right? That is your one scenario, right? So At the end of this class, in our next class, we will be doing test case, right? You will see by the time we start writing test cases, you will see how we are using all these techniques to write and design our test case and test scenario. So you can see now, I've now written first test case, which is my first scenario, right? So the scenario will now be when user has not filled or user left all the field blank, right? You are verifying if the submit button will become visible when user has left all the field blank. You've left all the field blank and you are checking if the submit button will become clickable, right? The expected result will be that this submit button will not become visible and clickable. If it's visible and clickable, it's a bug, right? So then you go again for your second scenario, right? You enter your name and leave the email and message and see if the submit button will become clickable. Of course, it wouldn't be clickable, right? You go again, you enter, you leave your name blank for another scenario, you enter your email and then leave the message blank. Submit button shouldn't be clickable. So that's how you go through it until you have left each one of them different combination of, yeah, you're leaving different combination, just like the decision table based technique has illustrated. Right? So this is why it is important. When you have your decision table based testing technique, right? You have you've drawn, right, this table this way, so it will become easy for you to actually, test all the possible scenarios, hereby giving this form a full test coverage. Is that clear? Any question here? I know why I'm personally asking for any question. Yeah, if there's no question, we'll move on to state transition. Right? So state transition is another one that would resonate with us as well. So with state transition, recall banking, your bank app, right? So let's say you are using Lloyd's Bank, right? You've downloaded the application, right? Not even Lloyd's Bank, most of the softwares and the application, right? When you try to, log in 3 times, right? So you've tried to log in, you've entered incorrect password the first time, right? It will say ask you to retry, right? You've entered it incorrect the second time. It will ask you to retry. You entered it incorrect the third time. What does it do? It will block your account. How many of us has had that experience? Anyone? You can use the reaction to let me know that you've had that experience. Or you can say yes. Have you used a particular website, right? You've tried once, maybe you are not sure what your password is. You've tried to, log in. You enter the first one, incorrect password. You enter the second one, incorrect password. You enter the third one, incorrect password, and your account was blocked. Good, good, good. Well done, blessed. I can see that thumbs up. Yes. So that is what state transition is. So let's say you as a tester, right? You are testing a mobile or a software, right? That says that, because this is a security measure that they are putting there, so that let's say someone is trying to guess your password. When that person must have tried it 3 times, it will lock or block your account or lock you out. It does happen with phone, right? So sometimes when I get my phone, I'll find out that, oh yeah, it has locked me out. because someone has tried it so many times, right? So it happens to anyone. I'm sure it has happened to us. It's common with banking app. It's common with your PIN when you lock, your phone, right? So now, what is state transition, right? So in state transition technique, changes in the input condition changes the state of the application under test, AUT. This is the first time you are hearing AUT, application under test. The reason why I'm using all these different terminologies, they are the same. Application under test is a software you are testing, right? You will see when you are in a meeting, stakeholders meeting, they are discussing the PAs. They will say, okay, yeah, what is the state of the AUT? They are testing, asking the tester. So AUT is application under test, right? So now, the more you impute, let's say, for example, right, you are testing that mobile app, right, banking app, right, that is a Lloyds Bank mobile app, right, and then you obviously have an account with them, right? So once you tried your password, the first one, and you enter the correct password, you will gain access to the website, to your mobile app, right? Your banking mobile app, right? So that is fine, because they've set it that once you try first and you get it correct, you gain access, right? The website, the software will record that you've only accessed it once, right? Once you've entered the first one and you got it wrong, you enter the second one and you got it wrong. No, you enter the first one, you got it wrong. You enter the second one and it's correct. It will give you access to your mobile, you will gain access and perform your transaction, right? So now there is another set of rules that say once you've tried it 3 times, your account will be blocked. So now you as a tester, if you want to test that kind of application, how do you do that? Obviously, you want to test every possible scenario, and you are using state transition technique. So how you do that is, one, as a tester, your happy part, you test if when you enter it once, if you gain access. Obviously, that should be yes. If you gain access, that's a pass, right? Because the requirement will state that once you enter once, you should get access, right? So now again, you as a tester, what you will now do is, for your second scenario, you will enter for your second scenario, you will enter your password. You will enter the wrong password the first time, right? Then it wouldn't give you access. It will say incorrect PIN or incorrect password, right? You will now enter the right one the second time. It should give you access. If you enter wrong password the first time and it gives you access, it's a bug. You flag it, right? But if you said incorrect password, right, now that scenario, step has passed. You will now enter the correct one. Remember, you enter the incorrect one the first time, and then you will now enter the correct one again. It should give you access. If you lock you or block you out, it's an error. It's a bug, right? Because the second one is not meant to lock you out, right? It's a bug. The second one, you are meant to gain access to your banking app, right? Then when you have tested it, then you will now have another scenario whereby you will enter the wrong password the first time, you will enter the wrong password the second time, you will enter the wrong password the third time. Or you can even enter the right password the third time. No, if you enter the right password the third time, so what you will do is that you enter the wrong password the third time for it to lock you out, right? So that's how it is done. So Like I said, tester can perform this action by entering various input conditions in sequence, right? That's why I will say first one, second one. So the guideline says transition should be used when a testing team is testing application for limited set of input values, right? Our PIN, all the password was set, most often when you enter it over and over again. So sometimes it mustn't be 3 times that you need to test it, depending on the requirement. If the requirement says that once you get your password, wrong password twice or wrong PIN twice, it should lock you out. If you get it wrong twice, it will lock you out, right? So now let's look at this diagram for better understanding, right? So now, like I said before, let's say your PIN on your phone, right? The rule says that, or the requirement says that if you enter your PIN once and get it correct PIN, you get access to your phone, right? So you as a tester, your first scenario will be first correct PIN entry, right? You've entered your PIN correctly the first time. Your PIN, you tried it first and it's correct, you gain access, right? Scenario pass. So the second one is you start, first of all, you want to get it wrong the first time. Your first try is wrong, right? You go to second try. When you try the second one and get it correct, you put correct PIN, you will get access, right? That is your second scenario. So your third scenario will be you get it wrong the first time, right? It will ask you to try again. You get it wrong the second time, It will ask you to try again. The third one, you get it wrong, it will block you off. Have you seen every possible scenario? Every possible scenario. Do we have any question? Good, Vincent. I was expecting that. Go ahead, ask your question.
I know, but I've asked the question on the chat anyway.
Oh, okay. Let me have a look. So what if you enter the wrong password for about 2 times? So, yes. So the question Vincent asked for the benefit of other people is, what if, I believe you all can see it anyway. So what if you enter the wrong password for about 2 times? We can also check if a warning pop-up tells you your account will be blocked if you enter the wrong password or the 3rd time. So now, thank you for that, Vincent. Let me keep this somewhere so that I can see when someone, yeah. Oh, 1 second. So I can see when someone asks any question. Yeah. So now, so Vincent, your question said if you enter the wrong password 2 times, right? So this is it. You've tried the first one, it fails. It says incorrect PIN. You try it the second time. When you try the second time wrong, it will still say incorrect PIN, right? First one, incorrect PIN. You try it the second time, incorrect PIN. When you put it wrong, incorrect PIN, because it will give you time to also try it the 3rd time. Did that answer your question? If you try it the first time, it says incorrect PIN. You try it wrongly, you enter the wrong one the second time, it will say incorrectly. It will give you time to enter the 3rd time. So if you enter the 3rd time incorrectly, right, it will block. But if you enter the 3rd time correctly, you will gain access. When the system has been set to for only 3 wrong entries. If the system is set for only 2, when the system is set for only 3 entries, it will lock you. But if it's set for only 2 incorrect one before it locks, if you try the first one, it will ask you to try. If you try the second time and it's incorrect, it will lock you out. So, but for this system, this software we are testing, with this diagram, this illustration, right? We are saying that it will only give you access to try it incorrectly, right? The 2 times. Then the 3rd time when you get it incorrectly, it will lock you out. But the 3rd time when you get it correctly, you will get access. That's why you have here, right? The 3rd time correct pin, you get access. But the 3rd time incorrect pin, block. Right? Is that understood? Does
Yes,
that answer
but
your question?
yeah, but what I'm trying to say is that because I've seen some application,
Mm-hmm.
like if you impute a password, like
Yeah.
a wrong password,
Yeah.
like an incorrect pin pops up, and you impute the second password,
Yeah.
like an invalid password,
Mm-hmm.
an incorrect pin pops up, and also you see something like a warning notification below
Mm-hmm.
telling you that if you enter the wrong one the 3rd time, your account will be blocked.
Mm-hmm.
You understand my point? So,
Yeah.
as a tester, also we can also test for something or recommend some such things to maybe a the developer or the BA that this will have things like this to make that system, that application user friendly, at least letting the informing the user beforehand that if you impute the wrong pin the 3rd time, this account will be blocked or this account will be locked. So that is what I was just trying to say. I don't
Yeah.
know if it is okay, if it is the right thing.
Yeah. So absolutely. Right. So that is when validation, what you have there is validation. Right. So error, sometimes they put that, you know, just to validate that, yeah, if you to inform the the user. But remember that it depends on, so most application now, or most application that has that functionality usually add that now, right? So, but you can recall that before, let's say with our mobile app before, it wouldn't tell you have to. But now, such error message, I would say, or warning message is the right word. Such warning message is being added now. Will inform you.
Yes.
So you as a tester, right? Your interest is if the functionality you are testing has got that warning message. You will also need to validate or to test that when excuse me, when you've entered the incorrect pin twice, that message will pop up. Do you get what I'm saying? You will also validate that message will pop up. If that message is on that, is was entered on that functionality, but sometimes you don't get it. So if you don't get it as a tester, it's good to recommend, because you're a quality assurance person, right? You're a quality assurance. You can recommend to the development team, right, that it would be good if we have this functionality, right? It would be good if we have this error message that is more user friendly, because they will know that, oh, I have tried 2 times, I have tried 3 times, that if I try again, I will be locked. So that way, the user will not try to log in again. And sometimes they will say you can try again. Let's say some of them will have an warning message, right? A validation message telling you that you can try when you are locked out. You can say you can try after 20 minutes, after 10 minutes, right? So if your requirement comes with all those things, you must validate it as well. And then as a tester, that's why we also participate in sprint planning, where we also look at the requirement. So you as a tester, Vincent, that's an important point that you raised. You as a tester, when you are testing this sort of functionality and you haven't seen that validation, that is when you will ask the BA or the PO, right? Do we need, I think it would be good if we have this warning message, so that um we can inform our user, right, that when they try the first and the second time, we will inform them that they only have one try, that if they do that, they will log them out. If that is not there, you will see that they will start having conversation, right? If it wasn't mentioned during the requirement gathering, sometimes it could have mentioned, been mentioned during the requirement gathering. But the BAs, most times, they are not more technical, right? They will forget to put that on their requirement. He will say, oh, yes, that was when he will remember it, and then he will not put it. If not, and he's not sure, he will say, okay, I will get back to the product team, right? I will get back to the stakeholder. So ask them if it's good, we'll add this. Then the stakeholder will say, okay, yes, you can add it, right? It will make our application more user-friendly, right? So they will add that. And then you as a tester, when you are testing this, you also validate those, warning message, right? So that is it. So we'll go to error guessing. We'll go to error guessing. So error guessing is a software testing technique based on guessing the error which can prevail in the code. So this one heavily rely on the experience, where the test analysts use their experience, right, to guess the problematic part of the application, right? So what this technique does is, so just as the name implies, you guess where the defects, could be, right? So most often you'll say, okay, I think we usually have issues around, login functionality, right? We usually have issue around login functionality. You go to login functionality and you test it, right? Oh, we have had report that several times our user always report that they can't click on checkout button, right? You go and click, test the checkout button, right? So it's based on your understanding of the system or the software, right? Your knowledge of typical implementation of errors, and then remembering of previous, trouble areas, the areas that usually get problem, and then if there is history that this particular website usually face. So in my one of the organizations I used to work before, so they said that, the around certain period when, customers usually access the website, right? So their system at some point usually break down, right? So what happens? So they will not ask us, they not ask me to write an automated test, right? That will ensure that the system doesn't break down. So at every point in time, I will go and check here, the system is still up and running within that period. Obviously, my test is running. Once the test passes, you know that it has breakdown. So you will be the first person to know, right? And then the development team will go and correct it as soon as possible, right? So now we are going to the next, which is the white box testing. Remember, previously I did mention the black box testing, right? And then we've gone through different types of black box testing, and now we are looking at the white box testing, right? So as you all know, the white box testing is a technique which focus on the internal structure, design, and the code, right? Like we said the other day, yesterday as well, in terms of black box testing. Now we are looking at the white box test technique, right? It focuses mainly on the internal structure of the application under test, right? It looks at the code, like I said, you consider the architecture, right? You look at how the logic is being written, right? So you have knowledge of it, and that will help you to adopt a techniques or cover test scenarios on how to test your application, right? So like I have on my slide, right? The code, like I mentioned yesterday as well, the code, is visible to testers, right? So it's also called a clear box testing, open box testing, or transparent box testing. These are mainly because you have access, to the code base, you have access to the structure, right? So yes, that is white box testing, white box testing technique. So we have different types of white box testing technique, right? So, but we as testers, like I've mentioned, we normally use the black box testing. The white box testing are mainly used by developer, but that doesn't mean that testers doesn't use this white box technique as well, right? So now we'll have types of black box testing technique, right? So first is system coverage. The first one we'll have is the system coverage, right? So the statement coverage, not system, statement coverage. The first one we'll have is the statement coverage. So statement testing exercise the potential executable statement in the code. So when when developers are writing the code, when they are building it, they put statements, right? So now when you are carrying out black box testing using this technique, you are looking at you are testing the statement, right, that is executable in that code. You are looking at the statement, you are saying, okay, yeah, these are the statements that that whatever statement they've made there is correct, because you are looking at the code. You are not looking at it from the front end part of test. You are looking at it from the back end, which is the code, while you are testing it. So we'll have decision coverage as well. The second one, decision coverage. So you are looking at in this types of white box testing technique, decision coverage, you are looking at your testing, you are carrying out decision testing exercise, right? The decision, which is the decision in the code, and the test the code that are executable based on the decision outcome, right? We are looking at the decision that is, the logic around the decision that is being written out the code, and you are carrying it. And like I say, it's also among the white box testing technique, mainly carried out by developers, right? So the reason why I'm going through it is so you know what they are, right? Then the next one is branch coverage. Branch coverage, right? So this technique check every possible part, right? The if-else statements, the if, the else-if, the loop condition, the conditional loops, and all that. These are all type of, branching, all type of logic and statement language, statement that the developers usually write, right? So in our own, when we get more matured with our automation, we'll begin to use all these if else, as if, conditional loop, we'll have the while loop, the for loops. We'll start looking at that, right? So these are for kind of white box testing. So what the developers or what the testers does on here is to ensure that when they execute that particular functionality, all those if, as if statements, that they are doing what they are meant to do, right? So now we'll go over to experience-based testing. Remember, at the beginning of the class, I told us that we'll have three categories: the black box testing, the white box testing technique, and the experience-based testing technique. We've touched on it briefly before going into what they are. So under the black box testing, we've mentioned the equivalent class partition, we've mentioned the boundary value analysis, we've mentioned the error guessing, we've mentioned error guessing, right? So which other one have we mentioned? We've mentioned the state transition, right? So yeah, so now we are looking into the experience-based. We are looking into the experience-based test technique, which obviously rely on the knowledge, skills, and the intuition of a testing team to design, execute, and evaluate test cases. So this depends on the experience of the tester, right, or the testing team. You as a tester, if you have experience, if you have knowledge about that website, so you use it to go into that website and then execute your test. So there are common example of experience-based testing, and that include exploratory testing. Exploratory testing is when you go on a website, you are not actually writing any You are not actually writing any test case. For exploratory testing, you are not writing any test case. So as a matter of fact, when you get a job in an industry, right? So what the first thing they do is, or the first thing you should request to do is to carry out, don't just go and start writing test case because you won't understand it, right? Maybe you are joining an industry in the middle of, the sprint. They've already committed story before you joined, right? You do not even understand their test case. You do not just say, oh yeah, let me just pick up. What you do is you ask for exploratory testing. Exploratory testing involve simultaneous learning, test design and test execution. Testers explore the application with minimal or no pre-defined test cases. You do not have any test case. You are not writing any test case with this regard. What you're doing is that you just go straight on the website and you start exploring. You start filling out the forms. You start trying to log in. You start trying to register. You start trying to perform anything on the application just to explore it, understand how it works, or look at where you are supposed to catch bugs, look at where there is validations, look at where, validation where you put your postcode if you will check, just to help you gain knowledge. So after you must have done enough exploratory, you've gained experience around that website. You can actually now go and say, yeah, this website, this is the way this website is functioning, right? So now the next one is ad hoc. Ad hoc ad hoc testing. I usually do ad hoc testing. Sometimes they'll say, maybe a client, will report that he's not sure, he or she is used to, performing a certain activity around that website, and he or she is not able to do that. And they ask, can you just carry ad hoc testing around this? You just jump in. It's not unplanned. You didn't plan it ad hoc. When ad hoc is something that is unplanned. It's not unplanned. It's not formal. There's no test case design in mind. You just jump in and you just start testing. So the benefit of this is that you go in and then you check if what the person is saying is true. If it is true, that means there is a bug there. Then you can now raise a bug. And after the development team has fixed it, you can now go back and retest it and then do regression testing around it, right? So the next one is what? Checklist testing. Checklist testing. So in this case, testers use a predefined checklist, right? You have your checklist. They've given you, most often I usually do checklist when we want to go live, right? I'll draw a checklist. Sometimes I can call it a regression testing checklist, right? So my aim is there are these functional parts that we want to make sure that nothing has that the developer code has not broken that functionality, right? So once before it goes, I'll use my checklist that I've done. I will not go into it. Okay, yeah, I can still see the login functionality, still clickable. I will tick it. I will go check. Okay, I can see the registration button. I can click on it and see the registration field. I will click it. I can see all the product item. They have their label and they have all the information that is meant to be there. I will click it. So that is what checklist based testing is, right? So we'll have other common type of experience-based testing technique. We have the one we call the monkey testing. The monkey testing is just, go randomly, test different parts of, it just as the name implies, right? The way when you see monkey in a bush, they keep jumping from one place to another, from one tree, from one branch to another. So that is another type of experience-based testing. You are testing based on the experience, right? So yes, and that is where we'll draw the curtain of the line for today, right? Any question?